So curve fitting with quadratic models, we're going to be looking at if they give us two things. They give us a set of data, and they want us to determine whether that set of data could represent a quadratic function, something we've done with linear models before, and we did it with exponential ones. And also, we're going to look at if they give us a set of points, we're going to learn how to find the quadratic function that will model those points. And I'm actually going to show you how to use your calculator to do it instead of doing it the way by hand. So I can show you how to do it by hand, but most of you won't want to do it that way. No. And actually, I think I will do one of them by hand so you can look at it and see how nice I am. So, okay. All right, now a reminder, when we were trying to tell whether a set of data was linear, we would check first differences. If we wanted to see whether it's quadratic, we would check the second differences. And if we wanted to find out if it's exponential, then we would check for constant ratios. So we're going to be looking at tell whether something's quadratic or not. So that means we're going to check to see if the second differences are the same. So here they give us a set of data, and they want us to tell whether this could represent a quadratic function. So we have to, first of all, check our x values and see if they are evenly spaced. So we got to find the difference between our x values, and what's the difference between each of these x values? Okay, all right, they're all different by 2, so we have that. So then we need to check the y values, and we're going to do the first and second differences. So the first difference, if you remember, that would tell us whether it is linear or not. And then so after that, we'll check the second difference. So always work your way from the end back. So 31 minus 17 is 14, okay, all right. And 17 minus 7 is 10. 7 minus 1 is, and what's 1 minus negative 1? 2, all right. So the first differences are not the same, so it's not linear. So then we check the second difference. So we're going to find the difference between those numbers. 14 minus 10 is 10 minus 6, and 6 minus 2. Okay. All right, since those are all the same, then this could be a quadratic function. So we have to make sure that the x's differ by the same amount, so they're linear. And check to see if the y's have a constant second difference. So letter B, for the x's, we have 3, 4, 5, 6, and 7. And the y's, 1, 3, 9, 27, and 81. So once again, first of all, we look at the x's. Are they changed at a constant rate? Yes. Okay, one every time. Okay. So we try the y's. Okay. What, Chris? Times by 3. So could the second differences be the same then? Right. Because they're being multiplied by 3, could the second differences be the same? Well, let's find out. Okay. We'll do a first difference. All right, we get 2, 6, 18, and what? 54, right? Okay. So the second difference, 4, 12, and 36. Okay. So because you said they're multiplied by 3, what kind of model should it be then? Nope, not cubic. Okay. It's exponential. Okay. Exponential, because the constant ratio would be the same, because each of the constant ratios are equal to 3, so it would be exponential. So this is not quadratic. Okay, and that's because the second difference is the same. So if you immediately see that it's a you multiply by the same amount each time, then you know right away it's not going to be quadratic. So writing a quadratic function from data. So I'm going to show you how to do this without your calculator, and then I'll show you how to do it with your calculator. And it's actually quite extensive to do it without. And so I'm actually going to give some extra credit for those people who do these without their calculator. And then I'll show you how you can use your calculator with using the regression feature of your calculator to do it. Okay. Now, so they give us these 3 points, 1, -5, 3, 5, and 4, 16, and they want us to find the quadratic function that fits those 3 points. Okay. Now, whenever I have 3 points, I can find a quadratic function that fits them. It just isn't always going to be nice values that happen. So, since we're trying to find a quadratic function, all quadratic functions look like this here, that f of x equals ax squared plus bx plus c. So what we can do is we can take each of these points represent x and y. So we can put the x value in for x in the quadratic, general quadratic function, and we can put the y value in for y. And what happens then is we can get some equations to where we can solve those equations by using the elimination method to be able to find the values of a, b, and c that give us that equation. So first of all, I'll take -5 and put it in for y, and I'll put 1 in for x. So we have a times 1 squared plus b times 1 plus c. Okay. So we're just putting the y value in for y, x value in for x. And I'll go ahead and simplify this. So we get -5 equals a plus b plus c. And I'm going to call that equation 1. That one's in black. All right. And then I'll put 5 in for y and 3 in for x. So 5 equals a times 3 squared plus b times 3 plus c. So 5 equals 9a plus 3b plus c. Right? And I'll call that equation 2. Okay. So all I'm doing is putting the x value in for x, y value in for y into the quadratic function. Then we'll do the third point. So we have 16 equals a times 4 squared plus b times 4 plus c. So 16 equals 16a plus 4b plus c. And that's going to be equation 3. Okay. So I'm going to use those 3 equations and do elimination to be able to get down to the point where I can find the values of a, the value of b, and the value of c to find the quadratic function that goes through those 3 points. So first thing I'm going to do is, and I've put the order of what I'm going to do here. So now I'm going to eliminate c first, because c is only, I have 1 c in each case. So all I have to do is change the signs of everything by using elimination. So I'm going to take the first and second equation and the second and third equation. I'm going to use them to eliminate the values of c. And if you remember the work we did with elimination, if I want to eliminate the value of c, that means that one of them has to be positive, one has to be negative, right? Okay. So if I change, I'm going to change all of these to be negative. So I'm going to multiply by -1. So we have 5 equals -a minus b minus c. Okay. So we get 10 equals 8a plus 2b. Okay. So I've eliminated letter c here. So I have one equation with a and b. So now I'm going to take equations 2 and 3, okay, and I'm going to use those to eliminate c also, because then I need to have two equations with a and b, so then I can eliminate one of those variables. So let's see, we have 5 equals. And what you use for your other equations is really up to you. And so this one, again, I want to get rid of c, so I need one positive, one negative, so I'll go ahead and multiply the first equation by -1. Okay, why do I want to do the first equation, not the second one? Or doesn't it matter? Okay, smaller numbers, that's right. So when we combine them, I get a positive values. So we get -5 equals -9a minus 3b minus c. So we have 11 equals 7a plus b. Okay. So I've taken those three equations and I've used them to eliminate c. So now I have two equations with a and b, and I'm going to call those equations 4 and 5, just so I kind of keep track of the things I'm working with. Okay? And we've worked with two equations before, right? Okay, we've done elimination with them, all right, and substitution to be able to find those values. And that's all we're doing is that method of elimination and substitution. We're just doing it starting out with three equations. Okay? Get rid of the easiest variable, which is c in each case, because there's only one c always. Now we can get it down to a quadratic, or down to two equations, so that we can simplify them. So I'm going to put them together. So now if I look at equation 4, is there something I can do with equation 4 to make that a little easier to work with? Here at equation 4. Okay. All right, yeah, they're all even, so I can divide by 2. So this would be 5 equals 4a plus b. So now if I put these two together, which variable is going to be easy to eliminate now? B. Okay. So we'll go ahead and multiply this one by -1 again, so that I can simplify easiest. So we get -5 equals -4a minus b. So we get 11 minus 5 is 6, and 7 minus 4 is 3a. So we get a equals 2. Now that we know what a equals, we can use this equation or this one to find b. Okay? Doesn't matter which one we use to find b. It's up to you. So I'm going to go ahead and use this one here, though. So we have 11 equals 7 times 2 plus b. Right, so the same procedure we used back when we were doing this in chapter 3. So b equals -3. Okay. So we now know the value of a. We know the value of b. We need to find c. So to find c, I'm going to go back to the original equations I had. Look at either numbers 1, 2, or 3 to use them to find the value of c. Jordan, which one's easiest of them? A, B, or C? Or 1, 2, or 3, excuse me.
2.
2 is?
No.
1 is. Why is 1 easier? Okay, yeah, because we just have A, B, and C, don't we? All right? So we'll take equation 1 then. -5 equals A, which is 2. B equals -3, and plus C. So C equals -4, right? We add 1 to both sides. So my function is then that f of x equals ax squared plus bx plus c. I have a quadratic function. It gives you this. Now, you remember us talking about, so here's how you do it by hand. Okay, pretty easy, right, Elise? You followed that completely, didn't you? Okay, all right. Now, that's doing it by hand. All right, there's an easier way. Okay. We've done we've used regression with our calculator, haven't we? We did linear regression, okay? But we haven't done quadratic regression, so we're going to learn how to do quadratic regression here. So if you remember how to use your calculator for regression, okay, first thing we want to do is put the data in our list. So in this case, the things that we're going to put in our list are going to be our values of x and y. Okay. So we're going to put the values of x in list 1 and the values of y in list 2. So go to your list, make sure they're completely clear. All right, so you have nothing in list 1, nothing in list 2. So we're going to put the x values in list 1 and the y values in list 2. So our x values are 1, 3, and 4. Okay. And we're going to put the y values, -5, 5, and 16 in list 2. Stat and edit. Right there, the first one. Just there you go. Okay, stat and edit's where your lists are. Everybody remember how to make a scatter plot so you can see them on our graph? Okay. Should already have a scatter plot on, so if you go to your y equals, make sure everything's clear there, and then turn the plot on. So which means I just go up, hit enter, and there's my plot. Okay. All right, and then hit zoom 9, and it should plot those 3 points. 1, -5, 5, what was it? 3, 5, and 4, 16. Okay. So first of all, we put the data in our lists, the x values in list 1, y values in list 2. And now we go back to stat. And where's our regression stuff at? Okay, stat and then over to calc. Okay, and we're doing quadratic regression, so that's number 5. Okay. Our x list is list 1. That's where we put our x values in list 1. We put our y values in list 2. You don't need to worry about frequency. But we do want to store this equation. So we want to put y1 there. And how do I get to y1? Do you remember that? Yep, alpha trace. Okay. Alpha and trace, and there's all of our y equals. So we go to y1 and then hit enter. Okay. And look there. There's the numbers we came up with for x, for a, b, and c. A is 2, b is -3, and c is 4. And if I graph it, they go right through my points. Okay, it's a perfect fit. So your answer then, whether you did it by hand like I did here, or whether you use your calculator like we did, it doesn't matter which way you do, your answer has to be this right here. F of x equals 2x squared minus 3x plus 4, because that's the quadratic function we just found. Okay? All right, so let's go through that process again together with these 3 points. Okay? So, Caleb, you got a problem?
What's this long equation in y equals?
Okay. Sometimes when you go to your y equals then, thank you for Noticing that? It doesn't show those numbers exactly as for some reason. Okay? So Caleb says, what's this long equation? Well, what's this number right here, Caleb? 2. Okay? All right, for some reason they've got about 18 zeros, and then they have probably and then a 1 and a 5 there before the x squared. Then they have, with a -3, they have a whole bunch of zeros. All right, so it's not exactly perfect, okay, but it's close. Right? So we would still just use these numbers here, 2, -3, and -4. Okay, so if we're doing the check it out together then, so let's write a quadratic function that fits these points. Put the x values in list 1, the y values in list 2.
How do you do the list again?
Stat and edit. So we have 0. Oops. So data in our list. We'll hit zoom 9 again to see what those points look like. Oh, forgot to clear my other graph. All right. So there's what the points look like on the graph. Yes, Zach.
Got like 9,000.
Really? Okay. It's because you got list 6, 7, and 8 there.
It doesn't have to go over anymore.
Okay. All right, go back to stat. And then where it says setup editor, hit that. What it did is that somebody was playing a game or messing around with it, and it eliminated those lists. So by hitting that setup editor and hitting done, then it will go back to, you have 1 and 2, yes. Okay.
You say the steps again.
Oh, yeah. We'll go back to stat. Then go over.
Did you put a minus sign there or the negative sign?
Then go down.
Okay, retype the -3 and see. Okay, let's try it again.
Hit.
Oh, you got, see that LN down there? End up down there somewhere.
No.
Oops. Zoom 9. There you go. Yep. Okay. So now we go to stat, over to calc, and number 5, quadratic regression. Everything else should be set. We just want to put y1 back in here. And here's our numbers. So -1, 4, and -3. So that means my function then would be f of x equals -x squared plus 4x minus 3. And that's the answer to this problem then. There's the quadratic function. All right, if I check it with my graph, see if it goes through them, and it does go right through those numbers. Perfect fit. Okay, we have we have our r squared is 1, which means it's a perfect fit, right? That correlation coefficient, we talked about that. Okay. Perfect fit of 1. Okay. Quadratic model is a quadratic function represents a real data set. So we're going to look at using some real sets of data and actually finding some real world answers to go along with that. So we're going to use our quadratic regression again to be able to find this. So here we have, this table shows the cost of circular plastic wading pools based on the pool's diameter, okay? You guys know what those are, right? Those little kiddie pools? Okay, we have one for our dog. He loves it. Yesterday he was just loving it big time. So says find the quadratic model for the cost of a pool given its diameter, and use the model to estimate the cost of a pool with a diameter of 8 feet. Okay? So where are we going to do with the diameter represents what? Okay, our x values, right? The cost is going to be our y values, all right? So go to your lists, put the diameter in list 1, and put the cost in list 2. Okay, and if you want, you can do zoom 9 again so you can see what the graph looks like. This definitely has the appearance of a quadratic function of going the way the curve is. Okay. And back to stat and over to edit or to calc, number 5. And then we really want this in our y equals because we need to find a value for a diameter of 8 feet so we can find out what that is. So alpha trace. Okay, so here are the numbers we get. Oh, they're fun numbers. So our function here is going to be that f of x equals 2.41x squared minus 21.56x plus 67.64. So go ahead and use 2 decimal places. There's the function model. And then they want us to use that model to find a pool with or the cost of a pool with a diameter of 8 feet. So either you can just stick 8 in here for x, or what else could we do? Do what, Jacob? We're at on our calculator. Can we go to find that? No. You could just go to trace, and let's see, we're looking for 8, right? Is this 8 the x value or the y value? Okay, it's the x value. So if I hit trace and type in 8 and enter, oh, it doesn't like me. Okay, anybody know why it didn't like me there? Anybody know why? Okay, because I'm on the plots, and there's not a plot within, so I would have to change it so that I'm on the equation. Okay? And if I type in 8 and enter here, it doesn't like it either. Okay, now the reason it doesn't like it now is because if I go to my window stops before I get to 8 for the x max. So the easier thing to do would be to go to your table and then go down to 8. And we get $49.54. So we're finding f of 8, and that would be, what did I say? 40 what? 49.54, right? There we go. Okay, all right. And so we found our function, and we found how much it's going to cost if the diameter is 8 feet. Okay? It's a pretty expensive pool. It must be made out of some pretty solid plastic. Okay? All right.